Nanofabrication is a difficult art. To practice it successfully and to develop it further, researchers need a highly controlled environment and a variety of instruments and specialty chemicals. The National Nanofabrication Center of the Center for Nanoscience and Engineering provides these to Indian researchers as they endeavor to create new nano devices and process technologies for future applications. But how does the NNFC create the precisely controlled, near-perfect conditions for carrying out sensitive processes? These could go wrong even with the minutest amount of dust, vibrations, electromagnetic interference, ultraviolet light, or other disturbances. The secret lies in several carefully designed and meticulously implemented systems and architecture, invisible to researchers in its work base. These make the NNFC what it is, a state-of-the-art nanofabrication facility comparable to the world's best. The design features that lend the NNFC its stunning contemporary profile were many months in the making. Its core design team spent nearly 3 years in planning, consulting, and detailing to outline its major constituent systems. These are summarized in a conceptual design document which served as the blueprint for the NNFC's construction over another 3 years. In this module of the guided tours of the NNFC, we will learn about the facility's heating, ventilation, and air conditioning system, or the HVAC. Professor Anil Kumar, a member of the NNFC's core design team, will walk us around the facility, explaining the design of the HVAC system and its performance objectives. As we begin the tour, let's ask Professor Anil Kumar for an overview of the day's learning agenda and of the role of the HVAC system at the NNFC.
Welcome to the National Nanofabrication Center at the Indian Institute of Science. The objective of this guided tour is to understand heating, ventilation, and air conditioning, or HVAC, the design of HVAC to maintain the required cleanliness in a clean room, the clean room fabric, etc. In this tour, you will learn what are the sources of contamination within a clean room. You will also learn what differentiates the conventional HVAC from the clean room HVAC. We are starting this guided tour at this location because this is the heart of the clean room facility. This is the utility building, and behind me you see this is the HVAC system which are located in this utility building, and behind me is the clean room facility. We will also discuss about the air filtration system, the types of airflow within the clean room, and also about the fan filter units. We will also discuss how we can control the relative humidity and temperature within the clean room.
The NNFC's enormous 10,000 square foot clean room requires constant flow of filtered, cool air and piped, chilled water. The chilling is provided by 3 industrial chillers located on the roof of the utilities building.
In order to maintain the required temperature within the clean room, you need air conditioning units. There are 3 air conditioning units here known as the chillers, and each of this chiller has got a capacity of 260 tons. You may be aware in your house you may have an air conditioning unit that may be 2 or 3 ton capacity depending upon the size of the room. Here, each of this chiller unit is having 260 tons of capacity, and this produces chilled water. This chilled water is used for cooling the air as well as cooling the process equipments within the clean room. The chilled water comes out of this chiller unit, gets into an air handling unit. Those 3 boxes which you see there with that blue color, they are the air handling units, or we call it as makeup air units. What does this makeup air unit do? It sucks air from the atmosphere, filters it primarily within that unit, and then cools this air with the circulating chilled water that is coming from the chiller unit, and then this cool air, primarily filtered, is pushed into the plenum of the clean room facility.
For round-the-clock cooling, the NNFC uses two 260-ton industrial chillers simultaneously, while a third stands by. Let's look inside one of these giant machines.
This is to get you the perspective of how big these chiller units are. For example, I am standing inside a 260-ton chiller unit. This is such a big unit. On the other end of this chilling unit, there is a compressor that is used for cooling the water. And the chilled water is stored in this tank, and these pipes take this chilled water to the air handling unit, as well as for different process cooling within the clean room.
The industrial chillers supply cooling water to 3 adjacent air handling units. Here, incoming fresh air is cooled with chilled water and then taken to the NNFC's plenum.
The chilled water that is produced from the chiller unit is coming through this pipe to the air handling unit. The temperature of this chilled water is kept less than 10 degrees centigrade, and this water goes through this pipe, and it passes through this pipe and comes here, and it reaches the air handling unit. This is one of the 3 air handling units that we have in this facility. The chilled water that gets into this air handling unit is passed through a copper pipe, and that cools the air that is coming inside this air handling unit. And then the remaining chilled water is coming back to these pipes and goes back to the chiller unit. And this water keeps on circulating, thereby cooling the air that is coming into the air handling units.
The 3 air handling units pull in ambient air and also provide primary filtration or removal of dust particles before sending the air to the clean room's plenum.
This is the part of the air handling unit where we will get the fresh air into the clean room. The fresh air is taken to this area and it is passed through this filter unit into the air handling unit. This filter primarily filters the big dust particles which is present in the atmosphere. So right now you see that these filter units are contaminated with the dust particles because this is in use for some time. Just to see how a new filter unit will look like. So this is a new filter unit. So this is not contaminated. With the time, this filter unit gets contaminated to that level, and we need to periodically clean the dust particle once it reaches a threshold value. Just to tell you that how the airflow in this particular region, if I throw some light particles here, that will move in the direction of the filter because air is getting into the filter unit. So just see this thermocol particles are moving into the direction of the filter units. This tells you that there is an airflow in this direction.
From the utilities building, chilled, primarily filtered air is brought to the NNFC's plenum. Here, an array of fan filter units takes over cleaning and circulation of air as per Nanofabrication specifications.
Right now, we are at the plenum of this clean room facility. I would like to emphasize that a clean room is a controlled environment where products are manufactured. It's a room where the concentration of the airborne dust particles are controlled to specified limits. These particles are generated by people, the facility, the equipments, and the process. These particles need to be continually removed from the atmosphere to maintain the required cleanliness. The concentration of allowed dust particles in this area is defined by the standards used, and Federal Standard 209E is a well-accepted standard in this regard. The airborne particles are physical entities with a definite dimension. It has a particle size ranging from 1 nanometer to 100 micrometers. To get a perspective, think about an influenza virus whose size is 0.1 micron or 100 nanometers. In modern day technology, most of the transistors that are being used in a modern chip has got a dimension smaller than this. Now this plenum area mainly controls the cleanliness within this clean room area. The air that is coming from the makeup air unit is still having particles because we have not removed all the particles from the atmospheric air. In this plenum area, the air from the makeup air unit comes and this air is filtered further through fan filter units, and this is one such fan filter unit in this area, and there are a series of fan filter units that are sitting at different locations. These fan filter units takes air from this area, filters through a HEPA filter that is sitting inside and pushes air into the clean room. Now you can see that there will be many dust particles that will be floating around here, and these particles will be removed by this fan filter unit when it enters the clean room. Thus, we maintain the required cleanliness within the clean room by a series of fan filter units that is sitting in this plenum area.
The fan filter unit is made up of a fan and a high-efficiency particulate air or HEPA filter. These remove 99.97% of dust particles with diameter above 0.3 microns.
Let us have a close look at the fan filter unit. Here you can see that a fan is rotating. This fan takes air from this plenum area and pushes into the clean room area. There is a HEPA filter that is sitting between the clean room and the fan that filters the air that is going from this plenum area into the clean room. Just below this fan filter unit, we will have the clean room.
The plenum, clean room and subfab form a three-tiered NNFC architecture designed especially for air circulation and other functionalities. The clean room's double side panels create a return air chase for air to flow back to the plenum.
This is the return air chase. Earlier we have seen that the air from the plenum area is pushed into the clean room through the fan filter units. This clean air from the clean room gets into the basement of the clean room or the subfab area, and that air is relatively cleaner than the atmospheric air, so we bring that air back to the plenum area through the return air chase. And this air is mixed with the fresh air that is coming from the makeup air unit and again pushes into the clean room area, and this process continues. Now, in order to create this return air chase, we have an outer wall and have an inner wall. This outer wall starts from the bottom of the basement area to the top of the plenum area. So this is a very long panel. Now we have an inner panel that starts from the bottom or the floor of the clean room area and ends at the roof, that is the beginning of the plenum area. So that is a relatively shorter panel that defines the height of the clean room.
To further understand the multi-featured system designed to keep NNFC air clean and flowing, we must know about 4 sources of contamination that bring dirt particles into the clean room.
Now, I will explain about different sources of contamination in a clean room facility and also about the airflow pattern inside. There are 4 major sources of contamination in a clean room. The first one is coming from the people. We are one of the biggest source of contamination. The second one is coming from the building material that is used to construct the clean room, namely the walls, the floor or the roof. The third one is coming from different processes that we are running inside the facility, and many of the byproducts of these processes are the source of contamination. The fourth one is coming from different equipments that we are using. The wear and tear of these equipments creates particles that becomes the contamination inside the facility. So in order to understand about these different contaminations, let us move into the facility and understand things more in detail. So this is the air shower region. In this region, we start cleaning the contamination that is generated by the people. So now the loosely bound particle which is attached to my body and the clothes is removed by this air shower. From this region, we will move into the gowning area where we will confine the dust particle generated by the people within this gown.
Since humans contaminate the clean room continually by shedding dirt particles, full body gowning is an important ancillary to the HVAC system.
We are now at the gowning area of this facility. As I told you earlier, people are the biggest source of contamination in a clean room. The skin flakes that is coming out or the hair that is coming out are becoming the airborne particles, then that contaminates this facility. So in order to confine these airborne particles within a confined area, we use the gowning before we get into the clean room. So this is a set of gown which I have, which will be used to protect the facility from the dust particles or the skin flakes that is coming from my body. So this is one gown and a head cover. So I first put this head cover so that will confine the hair within this head cover, and then I will put on this gown to cover my entire body. There are many other sources of contamination that is coming from human. One is the perfume that we are using. For example, the aftershave lotion or the body spray which we use gives gaseous particles. That's also a contamination as far as the clean room facility is concerned. And also when you are not well, that means if you are suffering from a cold or a sneezing and this kind of things, you are also not supposed to enter the clean room facility. Once the gowning is complete, now whatever skin flakes that is created within my body is confined within this smaller area. I also use a face mask so that the coverage of the exposed area to the outside world is minimum. And also I need to use a pair of gloves so that any flakes that is coming out of this hand is not spread into the clean room.
Building materials and clean room processes and equipment also generate contaminants. Let's see what special arrangement has been made by NNFC designers to contain these.
The next biggest source of contamination in a clean room is from the building material. For example, the floor tiles, the wall or the roof. Here we chose the roof, the wall panel as well as the tiles such a way that it has the lowest outgassing possibility and also it sheds minimum particle inside the clean room. The entire clean room is made up with honeycomb panels inside the clean room, and the outer shell of the clean room is made with rock wool filled panels. Now as you move further, you will see we have different equipments in this clean room. These equipments are also many a times shed particle because there is a lot of wear and tear. Many of the parts are moving at high velocities and sometimes they are at higher temperatures. So this sheds particles into the clean room. So we are also making sure that this contamination is also minimal in this clean room. And also as you move along, you see there are many process equipments within this clean room. These processes also create contamination in this clean room. And as far as possible, we are taking the process exhaust outside the clean room so that this process is not contaminating the clean room. So that makes sure that we have the airborne particle density at the tolerable limits.
To prevent swirling dust particles, air is made to flow laminarly from the ceiling to the floor using a dense array of HEPA filters and perforated floor tiles.
Now we are at the wet edge area of this clean room facility. some time back, I was explaining about the fan filter units. I was showing you the fans which are rotating at the plenum area. Then I told you that on the other side of the fan filter unit, there are HEPA filters. And this is the fan filter unit. Here, the HEPA filter is on this side of the clean room, where the particles are filtered. This is a high efficiency filter. This has got filtering capacity for 0.3 micron dust particles and above. So the air which is pushed into this clean room passes through this room and enters to the subfab area through this perforated tile. So the basement of this clean room is connected to the plenum through the return air chase. Now this air which is flowing through this room is almost laminar. Now I am sitting on a working table, and you may wonder why there are perforations on this table. So these perforations are such that it will not alter the airflow pattern within this room. When the air comes here and it passes through this table and it goes through the perforated tiles down. Suppose if there was obstacles, that will alter the airflow pattern. And also here, the number of fan filter units and the number of perforated tiles are designed such a way that to maintain a class 1000 condition in this clean room. And also the design is such a way that there is no area where there is stagnant air. That means if there is stagnant air, the dust gets accumulated at that area. So we should always make sure that the entire area has got moving air. Now, when you move from this class 1000 area to a class 100 area, you will start seeing dramatic changes. Now you have only partially covering of the fan filter units at the roof and also partially covered perforated tiles at the floor. Now when you get into the class 100 area, you will see there is 100% filter coverage at the roof and also sufficient perforated tiles at the bottom so that the complete laminar flow and the cleanliness is maintained.
The 10 times cleaner Class 100 lithography area uses a denser pattern of HEPA filters and perforated floor tiles. The flow is kept steady at a rate that changes cleanroom air nearly 400 times every hour.
Now we are standing at the class 100 area of this cleanroom facility. This class 100 area is quite different from the class 1000 area which we have seen earlier. For example, if you look at the roof of this facility, you see almost 100% coverage of the filters at the roof. So there are 100% coverage with the fan filter units at the roof. Because of that, you have a different type of lighting at the roof. These are the teardrop lights. Similarly, if you look at the floor, you will see that the floor coverage with the perforated tiles is much more than what you saw in the class 1000 area. Now, what distinguishes a cleanroom HVAC from the conventional system? First of all, you have fan filter units that arrest the particles from entering into this room. And second thing is that the number of air changes per hour. In this room, we have more than 400 air changes per hour, whereas in a conventional HVAC which we use at our house, it is having 2 to 5 air changes. And also this room is now pressurized compared to the outside. So this is almost like 30 Pascal higher pressure than the outside pressure, whereas in your house you realize that there's no pressurization within the room. So these are the things that distinguishes the conventional house air conditioning to the cleanroom HVAC.
Finally, let's step into the subfab and see how air flowing through the floor tiles comes here, is filtered, cooled, and then sent up via the return air chase.
I have removed 3 floor tiles from this cleanroom area. Now I am removing the 4th tile to have a better visibility. I am now standing inside the subfab area or the basement of this cleanroom facility. I have explained to you earlier that the air enters into this cleanroom through the fan filter units from the plenum. And the air that is in the cleanroom is taken to the subfab area through the perforated tiles at the floor. The air that comes into the subfab area or the basement of this cleanroom is passed through this kind of cooling coils. So the air after passing through this cooling coil is taken to the return air chase and it is brought back to the plenum of the clean room. And this process continues, and that maintains an airflow from the plenum to the subfab area and maintaining a cleanliness within the clean room.
On this tour, Professor Anil Kumar acquainted us with the important aspects of the heating, ventilation, and air conditioning system at the NNFC. To learn more about other design features, please watch the remaining videos in this educational series. Thanks and goodbye from the NNFC.